Good morning, students. Good afternoon, students. Uh, Please let me know whether I am clearly audible.
Yes, sir, you are audible.
Yes, sir.
Yes. Okay, thank you. Thank you, Pradeep Vaishnavi. So again, I would like to welcome you all for the 13th session on the course of thermodynamics. Presentation. Student, please let me know whether the presentation screen is visible.
Yes, sir.
Okay, thank you. Let's wait. Let's wait for a minute. So far, only 10 students joined the session. Again, I want to share one thing with you. There is one platform. I hope you are aware with this NPTEL SOEM courses. So again, there is a course available on thermodynamics. So I request you to join that course. I have also enrolled for that course, and that course is starting from 14 September. So again, I request you to join that course. These courses are conducted by the IIT faculty, and again, there is a regular assessment of week-wise assessment of the course. So in previous session, we started unit number second. Unit number second is first law of thermodynamics. So in previous session, we started unit 2 with statement of first law of thermodynamics. Before coming to the first law of thermodynamics, we all are aware with the law of conservation of energy, which says that neither energy is created nor it is destroyed. It will only change its form. So energy will change its form from one energy to the another energy. So for that we have taken an example of the electrical fan, a common application. Student, please ensure while joining the session, your audio is muted. Okay. So we are taking a common example of an electrical fan. So in electrical fan, electrical energy is the input, and that electrical energy is converted into mechanical energy, and thereby the fan circulate air throughout the room effectively. There is effective circulation of the air throughout the hall. Okay, so there is conversion of energy. Electrical energy is converted into mechanical energy. So that is law of conservation of energy, and first law of thermodynamics. Law of conservation of energy is based to the derivation of first law of thermodynamics. So again, we know thermodynamics is entirely based on heat and work, conversion of heat into work, and vice versa, work into heat. So first law of thermodynamics again correlate heat with the work. So if you want to get a statement of first law of thermodynamics applicable to any process that is happening in the surrounding, so the statement of first law of thermodynamics is net heat transfer net heat transfer minus net work interaction, that is equal to change in internal energy. This is the statement of first law of thermodynamics applicable to any process. And if you apply again first law of thermodynamics to a system undergoing a thermodynamic cycle, so the statement of first law of thermodynamics will modified as, because we know when a system execute a thermodynamic cycle, then change in internal energy, sum of all the internal energy in a cycle, it will be 0. So the first law of thermodynamics modified to the thermodynamic cycle as cyclic integral of del Q is equal to cyclic integral of del W. So del is a symbol of inexact differential. So heat and work are inexact differential. We learn in first unit. These are the transient energy path function. So they are the inexact differential. That's why a del is written in front of the heat, and this del Q indicates the net heat transfer. So if we take a cyclic integral of heat transfer, that is equal to the cyclic integral of work interaction. This is the first law of thermodynamics applicable to a system undergoing a thermodynamic cycle. So let's take an example for understanding the first law of thermodynamics. So we take an example of a closed system. So commonly we are taking piston cylinder arrangement as a closed system. So if you observe this diagram carefully over the slide, so there is a piston, this is the piston, this portion is piston, okay, and this one is cylinder. So this piston is freely reciprocating inside a cylinder, and this reciprocation is without any friction. So there is a frictionless motion of piston inside a cylinder theoretically. And if you want to understand what is exactly happening in a piston cylinder arrangement, suppose this piston cylinder arrangement is filled with a certain gas, and if we start to heat this gas, means if we start to add heat into the gas, what will happen? So first of all, here understand this piston cylinder arrangement along with the gas is our system. It is a matter we want to study, or it is a space where we want to apply laws of thermodynamics. So this piston cylinder arrangement is our system along with the gas that is filled inside a cylinder. And so which one is the boundary here? Can you tell me? What will be the boundary of this system?
Sir, cylinder is a boundary.
Absolutely correct. Wall of the cylinder. So this one is the boundary. So this wall of cylinders are the boundary, real boundaries. Okay, and fixed boundaries. And this piston is the surface of the piston. Bottom surface of the piston is again a real boundary, but this boundary is movable. Okay, so these three walls of cylinder are the three boundaries, and one fourth boundary is the surface of the pistons, and this is a movable boundary. Okay, and anything outside the system is the surrounding. Okay, so this is the surrounding here. Unmute yourself. Some mic is on. Again, I am requesting all the students, ensure that your mic is muted while joining the session. You can unmute yourself if you have any doubts, any questions, because these are unnecessarily creating disturbances. So this is our system. So how first law of thermodynamics is applicable to this system? Let's try to understand. Suppose the heat is supplied to this system, that is heat is added into the cylinder. So this heat, first this heat will be transferred to the material of the cylinder through conduction. We studied various modes of heat transfer. So heat will be taken by this material of this cylinder, walls of the cylinder. So through conduction it will get heated, and then from the walls of the cylinder the heat will be transferred to the gas, and the mode of heat transfer will be convection. So as soon as the gas gets heated, its molecules start to move away from each other. So there is increase in internal energy of the molecules, and these molecules will start to move with high energy, and this particle will push this piston upward as shown by this blue arrow. So piston will move upward, and as we know, if there is a flow, a displacement work come into picture. Okay, So due to this movement of this, due to increase in internal energy of the gas molecules, there will exert a pressure over this piston, and this piston will move upward, and we get a work, and that work is in the form of displacement work. Okay, so according to this, if you apply first law of thermodynamics to the system, so it will be heat transfer minus work interaction, that is equal to change in internal energy. So in this system, as heat is supplied to the system, so it will have a positive sign. As work is produced by the system, again it will have a positive sign, and again there is increase in internal energy of the system. So there will be rise in internal energy. Okay, so this is the first law of thermodynamics applicable to the closed system, that is piston cylinder arrangement. Similarly, you can apply first law of thermodynamics to the any system. Let's take an example of a pressure cooker. Pressure cooker is an example of which type of system? Students, please let me know. Pressure cooker is example of which type of system?
Isolated.
What are the different types of system?
Open, open, close.
Closed system, open system, isolated system.
Absolutely correct. Perfect. Very good. So there are three types of system: open system, closed system, and isolated system. Open system is also called as the control volume system. Closed system is called as the control mass system. And third one is the isolated system, where there is no transfer of mass as well as energy from the system. So this pressure cooker is example of which type of system? Students, reply. Pressure cooker. It is a very common thing. It is commonly used in a kitchen. Almost at every house.
Sir, it is closed system.
Absolutely correct. Perfect. Pressure cooker is an example of a closed system, because if, whatever food we are cooking in a pressure cooker, it will not come out of the pressure cooker. Okay, so mass will not come out of the pressure cooker, but energy transfer will take place, because that food gets cooked and again excess heat is released along with the steam. Okay, so heat is transferring, heat is crossing the system boundary, but mass will not cross. So pressure cooker is an example of a closed system, which is very important application of the thermodynamics, pressure cooker. So it is a closed system. So according to first law of thermodynamics, again in pressure cooker, whatever heat is transferred, that is equal to change in internal energy. What about work in case of pressure cooker? What will be the work interaction in case of pressure cooker? Is pressure cooker required any work, or either it will produce any work? Students, what is the energy input to the pressure cooker?
Provided by fans.
What is the energy input? Which energy is input to the pressure cooker? Which form of energy?
Sir, heat energy.
Absolutely correct. Perfect. Heat is energy input to the pressure cooker. And again that heat will be converted, that heat will change its form, and there will be increase in internal energy of the food that we are going to cook in a pressure cooker. So the internal energy of the molecule of the food will increase. Okay. So heat energy is converted into internal energy, increase in internal energy. So their work will be zero in case of a pressure cooker, because it will not produce any work or it will not consume any work. Clear? Okay. And if you want to get a specific form of the energy equation, or if you want to get a specific form of first law of thermodynamics, we need to divide each term in the mathematical equation with mass of the system. Okay. So if we divide heat, we are denoting with capital Q. So if we divide heat with M, so it will be small q, and its unit will be, so its derived unit will be kilojoule per kg. So this is specific heat. Similarly, if we divide work with mass, so it will be again specific work. Okay, and again if we divide change in internal energy with m, so it will be specific internal energy, small u, delta small u. So the mathematical equation will be Q minus W is equal to delta U, small u. And again you observe here, in general form, the unit of each term in the equation is in kilojoule. And if you write this equation in specific form, the unit of measurement will be kilojoule per kg. So each term will be measured in kilojoule per kg. Okay. So this is the energy equation on mass basis, and this is the energy equation on time basis. I hope you understood first law of thermodynamics. Now, whenever any law is invented, it needs a proof. Okay. So first law of thermodynamics is proven by the scientist named Joule. So for that, Joule conducted one experiment. Later on, that experiment is famous with the Joule's experiment. I think you have learned this Joule's experiment in elementary science, 11-12 science. Okay. So for that, Joules have taken one container, a vessel, which is totally insulated. So this is a vessel. Okay, a cylindrical vessel which will have over this vessel a insulation is provided, and Joules consider that this insulation is perfect one. What do you mean by the insulation vessel? Insulated vessel means there will not be any heat transfer. So here through this vessel heat transfer will be correct, perfect. Heat transfer will be 0. So Q will be 0. There will not be any heat will not be added, or any heat will not be rejected from this adiabatic vessel or insulated vessel. Okay. So in that vessel, a stirrer is fitted, and the stirrer is having pulley at another end, and through wire, the end of the stirrer is connected to a pulley through a rope or a wire, and at the end of wire a weight is attached. Okay. Suppose the mass of this block is m, so the weight which is applied over this rope is mg, mass into gravitational acceleration. Okay, and this mass is allowed to lower through a distance h. Okay, so at this block is having a potential energy which is given by mg. So when this block will move from this position to this position, its weight or its kinetic energy will get converted into potential energy. Okay, and this container is filled with water or some another fluid. So let's take this container is filled with a water. Okay, and a thermometer is fitted inside a vessel to measure the change in temperature. Okay, so initial temperature is measured when the block is at initial position, and as soon as the block is released, so due to its own weight, so due to its own mass, there will be force over this block, and due to that force the block will come down. So its weight get converted into potential energy, and it will come downward through a height h. Okay, so due to that, what will happen to the stirrer? So this stirrer will start to rotate in a water. As this vessel is insulated, due to rotation of this stirrer inside a water or a fluid, the internal energy of the fluid will increase, and due to this the temperature of this water or fluid will increase. So we measure that temperature, rise in temperature of the water. Suppose initial temperature is T1. So Joules measure that initial temperature. Suppose that temperature is T1 and T2 is the final temperature. So both temperatures are recorded, And by using this temperature, Joules calculated the change in internal energy, that is delta U, and this delta U is equal to mass into specific heat into delta T. So what will be the value of delta T? So value of delta T will be T2 minus T1. So this change in temperature dt will be T2 minus T1. And where C is the specific heat of water, which is 4.18 at room temperature, 4.18 kilojoule per kg Kelvin, and we know how much amount of water is filled inside the vessel, so we know the mass of vessel. So from this we can calculate the change in internal energy. So Joules calculated the change in internal energy of this fluid, and again Joules at the same time Joule also calculated the potential energy. So mass of this block is known, gravitational acceleration is known, and the distance through which this block is displaced, that is h, it is measured in meter. So from this Joule calculated the potential energy, and at the end of experiment Joule found that this potential energy is approximately equal to the rise in or change in internal energy. Okay, and this is nothing but a first law of thermodynamics. So by this way the first law of thermodynamics is proven by the Joules, and this whatever experiment Joules conducted, it is famous with the name Joules experiment. Okay, so this is regarding the statement of first law of thermodynamics and its proof. Now we are going to apply this first law of thermodynamics to the various types of system. Okay, so first start with the isolated system. So if you apply first law of thermodynamics to the isolated system, what will be the changes in first law if it is applied to isolated system? So what will be the amount of heat transfer in case of isolated system? कितना होगा हीट ट्रांसफर आइसोलेटेड सिस्टम में? स्टूडेंट्स, what will be the amount of heat transfer?
It will, sir, only a temperature will rise and internal energy will remain zero.
Internal energy will remain zero.
Yes, sir.
I am asking you what will be the amount of heat transfer? कितना heat transfer होगा? Okay, doesn't matter. You all are in learning phase. Okay, so whenever the system is isolated, the amount of heat transfer will be always zero. So Q is zero. Correct? Isolated system, as we define heat and work as boundary phenomenons, they are observed only across the system boundary. So in isolated system, work will be zero. And what is first law of thermodynamics applicable to any process? Q minus W is equal to delta U. Correct? This is first law of thermodynamics applicable to any process, any type of system. Okay, so we are going to put this condition in this equation. So this equation will be du is equal to 0. Okay, for isolated system, the first law of thermodynamics will be change in internal energy is equal to 0. What it means? What will be the change in internal energy? Suppose that isolated system is undergoing change in state from 1 to 2. So change in internal energy will be U2 minus U1. So it will be 0. Or we can write U1 is equal to U2. So for isolated system, internal energy remain constant. This is the first law of thermodynamics applicable to isolated system. But this will not happen because isolated system does not exist in a nature, or it is very difficult or almost impracticable to develop a isolated system or a device which is perfectly isolated. Are you getting this? So for isolated system, change in internal energy will be zero as there is no heat interaction, there is no work interaction. Okay. So left hand side of this equation will be 0. So we can write change in internal energy is equal to 0, and from this we can conclude initial internal energy equal to final internal energy. So for isolated system, the first law of thermodynamics is change in internal energy is equal to 0. Clear? Now let's come to the another type of system. Let's apply this first law of thermodynamics to the closed system. So closed system is also called as the control. What is the second name to the closed system? क्या होता है? Control mass system, where mass is controlled. There is restriction to the flow of mass. So that type of system is a control mass system or closed system. Okay. So let's take an example. A gas inside a piston cylinder arrangement. Okay. So this piston movement is restricted by putting a stopper here. So these are the two stoppers. Okay. And again, the closed system will undergo 4 type of thermodynamics process. So first process is constant volume process. That process is also called as the isochoric process. So while learning fundamentals, we studied when volume is kept constant, what is the relation between pressure and volume? Sorry, pressure and temperature?
Both are dependent on each other.
Absolutely correct. Perfect.
Directly proportional.
Directly proportional. Correct. Perfect. So when volume is kept constant, pressure is directly proportional to the temperature. This is according to which law? What is the name of the law which give relation between pressure and temperature at constant volume? Charles law. Charles law gives relation between volume and temperature. Example is hot air balloon. Correct? हॉट एयर बलून में क्या होता है? जैसे जैसे एयर का वॉल्यूम बढ़ता है और जैसे जैसे टेम्परेचर बढ़ता है एयर का उसका वॉल्यूम भी बढ़ता है, एंड देयर बाय द बलून start to move in upward directions along with the number of person in a basket. The basket is fitted to the balloon. Okay, that is the example, real life example of Charles law. And according to that, when pressure is kept constant, volume is directly proportional to temperature. And here volume is kept constant and pressure is directly changing with the temperature. So it is Gay-Lussac law. Okay, remember this. Okay, so we are going to apply this first law of thermodynamics to the closed system which is undergoing a change by keeping volume constant. Okay, so that's why it is named as first. So let's take an example of a piston cylinder arrangement. Here there is restriction for moving this piston inside a cylinder by putting a stopper. So fixed stoppers are put here. So piston will not move in upward direction. Its movement is restricted, so it will not allow to move in upward direction because there are stoppers, fixed stoppers, which will not allow these pistons to move in upward direction. But piston may move in downward direction. Okay, and this arrangement is filled with a gas, and if we start heating the gas, suppose heat is added, so what will happen due to addition of heat into the gas? the temperature of gas will increase. So again we studied law of conservation of energy and first law of thermodynamics. So this heat will get converted into another form of energy, and that another form of energy is internal energy, because work is not possible. This piston movement is restricted, so there will not be any displacement work. So displacement work will be 0. Okay, and let's represent this change in state of the system on PV diagram, pressure volume diagram. Okay, so this is a PV diagram. Initial state before starting the burner, the system is at state 1. So it is having a volume of V1 and pressure of P1. Okay, so that point number 1 is plotted here on PV diagram. And after adding heat, there will be a rise in pressure of this gas, as well as temperature will also increase. So let's say the state is represented with 2, which is having a volume of V2, and again V1 is equal to V2 and pressure will be P2. Okay, so again we define while studying the form of work interaction. So this displacement work is given by integral of PdV, as dV is 0 in case of constant volume process, so work will be 0. Okay, and according to first law of thermodynamics applicable to any process, the first law of thermodynamics is change in internal energy is equal to heat transfer minus work interaction. So work is 0, so what is remaining? Heat transfer Q is equal to du, and du is nothing but a change in internal energy, that is U2 minus U1. Okay, so this will be the amount of heat transfer in case of constant volume process, and work will be 0. Okay, so here heat get converted into rise in internal energy of the system. Okay, so this is the first law of thermodynamics applicable to a closed system undergoing a constant volume process, constant volume heating process. So there is heating in this system, gas inside this system is heated. Okay, so this heating is carried out by keeping volume constant. That's why this process is constant volume process or isochoric process. Okay, so whenever a closed system undergo isochoric process, then it's the first law of thermodynamics will be Q is equal to del U, or change in internal energy or increase in internal energy. Clear? Is there any doubt? Please let me know. Students?
No doubt, sir.
Okay. Other students, are you there in a lecture?
Yes, sir.
Okay.
No doubt, sir.
Okay. Now let's come to the second process. A closed system undergoing a constant pressure. Okay. So again, let's take a same example. Piston cylinder arrangement. Stoppers are removed. Okay, and the gas is heated by keeping the pressure constant. Now what will happen? If the stoppers are removed, what will happen? There is no restriction for moving the piston. So as soon as the heat is added into the gas, the internal energy of the molecule will increase and they will start to move. They will start to move with higher energy. Okay, and they will exert a thrust or a force over this piston, and this piston will move upward, and so there will be a displacement work. Okay, and again the change in state of the system at constant pressure, suppose initial state is 1, final state is 2. So before adding heat, the state of system is 1. So here volume will be V1, pressure will be P1. Correct? Again, as soon as heat is added, there will be increase in volume of the gas inside a piston cylinder arrangement, and at the same time the piston will also start to move in upward direction. So there will be a displacement work. So final condition or final state of the system is 2. So here volume will be V2, capital V2, and pressure will be P2. But here P1 is equal to P2. Now let's see what will be the displacement work. So again we know displacement work in closed system or non-closed system is integration of PdV. So here dV will not be 0, and this work this will not be 0. So this work is equal to P into what will be the integration? Limits will be 1 to 2. Initial state, final state, or initial limit minus final limit. And what will be the integration of dV?
P into V2 minus V1.
Correct. So integration of dV is V, and if you put the limit, it will be V2 minus V1. Okay. So first law of thermodynamics, again we know it is du is equal to Q minus W. Okay. So what about the amount of heat transfer? So it will be Q, work is W, and change in internal energy will be U2 minus U1. So this will be the first law of thermodynamics applicable to a closed system undergoing a constant pressure process, or that process is also called as the isobaric process. Okay, and here work interaction is given by P into P2 minus V1. This will be the displacement work in case of a closed system undergoing a constant pressure process. Clear? Now let's come to the third process, important process, which is carried out by keeping temperature constant. Okay. So again consider the same system. Here again there are no stoppers. Okay, and gas is heated, but this heating is carried out by keeping the temperature constant. Okay, and suppose the initial position is 1 and the final position here it is with A and B. So for our convenience we take initial state of the system as 1 and final state of system as a 2. Okay, and the gas will expand, and during expansion the piston will also move, and due to movement of piston there will be a work, displacement work. Okay, and again whenever temperature is kept constant, what is the relation between the remaining two, that is pressure and volume?
They are inversely proportional to each other.
Absolutely correct. Perfect. So whenever temperature is kept constant for ideal gas, pressure will vary inversely with the volume and vice versa. Okay. So P will inversely varies with 1 by V. Okay. And if you introduce a constant, proportionality constant, so it will be P is equal to C by V. Okay, or it is PV equal to constant. So this is the characteristic equation of a isothermal process, or a process in which temperature is kept constant. Okay, so the process in which temperature is kept constant, the name to that process is isothermal process. Okay, so if we apply this here, so we can write P1 V1 is equal to P2 V2, and again we know displacement work is given by integration of PdV, where P is equal to C by V. Okay, so we replace value of P with C by V. So the equation will be integration of C dV divided by V. Okay, C is constant, so it is taken out of the integration, and integration of dV by V. What is integration of dV by V?
Log of V.
Absolutely correct. So it will be C into log of V, log to the base E V, and limits 1 to 2. Okay. So this work will be, again C is equal to P1 V1. So work will be P1 V1 ln of, instead of log E, log to the base E, we can write ln of V2 by V1. So this will be the amount of displacement work in case of a isothermal process, closed system undergoing a isothermal change. Okay. Now here in this process temperature is kept constant, and again we know internal energy is function of temperature. So as temperature is kept constant, so this U2 minus U1 will be 0. Whenever temperature remain constant, change in internal energy will be 0. Okay. So if we use this condition of isothermal process in a first law, so Q minus W is equal to 0. So we can write Q is equal to W is equal to constant ln of V1 by V2. Okay. Or it will be Q equal to W is equal to this one. So this will be the amount of heat transfer as well as work interaction in case of a closed system undergoing a constant temperature process. Clear? Okay. So we apply first law of thermodynamics to a closed system undergoing a different thermodynamic processes. Started with constant volume, that is isochloric process, constant pressure, isobaric process, and then third constant temperature process, or it is a isothermal process. Is there any doubt, student?
No, sir.
Okay. So I hope these much contents are sufficient today. So we'll stop here. Please wait for a moment so that I can download the attendance.